Alright guys, borrowing a bit from Mr. Barton, lovely English man with a good math site. You can check it out at mrbartonmaths.com. Today we are looking at the sine and cosine rules. This is 4.7 and 4.8 from your textbook. Let's have a look and see what's coming up. So, up until now, when you're dealing with trigonometry, we've only looked at right-angled triangles. You can see there in red. They only work for right-angled triangles, but in actual fact, trigonometry can work for non-right-angled triangles as well, and that's what the sine and cosine rules do. They help us find missing sides and angles in non-right-angled triangles. Now, the sine rule we will look at first. Two things you can do. You can find an unknown side or an unknown angle. Here we're looking at finding an unknown side, and here's the formula. A divided by sine A equals B divided by sine B equals C divided by sine C. You'll notice lowercase letters and uppercase letters. Uppercase letters, angles. Lowercase letters, the opposite sides. So you can see they match up there. So, when would I use a sine rule? If I'm given at least one opposite pair, so either A and A, or B and B, or C and C, and it's totally arbitrary what you want to call them when you're actually doing the problem. As long as I've got one opposite pair and one other bit of information, I will be able to solve the triangle. In this case, in the example down here, we have a triangle where we are given one opposite pair. I'm given the side 7 opposite the angle 42. And I've got another angle 37 and I want to find the missing side. So, using my rule, when you want to find a side length, you want the lowercase letter. So I'm going to put that on top. So you can see they've got A divided by sine A equals B divided by sine B. Then I just fill in the blanks. So the one I'm looking for, x divided by the opposite one, sine 37, would be the same as 7 divided by sine 42. They've got that there. How do I get x on its own? Is even, labelled is working, good man. Multiply each side by sine 37. Push buttons on your calculator, 6.3 centimetres. Check that it sounds reasonable. 7 is opposite an angle of 42. 37 is a little bit less than 42, not a lot less. 6.3, it's a little bit less than 7, not a lot less. That sounds pretty reasonable. That's not too hard. Let's have a look at the next one. Finding an unknown angle. Again, you need to be given an opposite pair. But notice they've found the reciprocal of each term in the formula. If A divided by sine A equal B divided by sine B equal C divided by sine C, then the reciprocals should be equal also. Now, in this case, we're looking for a missing angle. So here's an example. We've got a side length of 16. I want to know how long that angle is opposite the 16 centimetres. I know that I've got an angle of 37 opposite a side length of 11. So we write it out the same way. Sine A on A equals sine B on B. Replace the values that we know. So the pair that I know are 11 and 37. So sine 37 divided by 11. Sine X. X is the one I'm looking for, divided by 16. I multiply through by 16 and I get sine x equals 0.8753. Remember, to get x on its own, you have to do the inverse function of sine, which we call arc sine. Looks like sine to the power of -1 on your calculator, but it's not a power, it's the inverse sine function, or arc sine. Do that on your calculator and you get 61.1 degrees. Not too bad. Seems reasonable. 61.1, opposite 16 should be larger than opposite 37. And 11, that sounds pretty good. But there's something Mr. Barton didn't include, so I've added in an extra slide here. Let's have a look. What about the ambiguous case? We know about the unit circle, and at the very least from 4.6 you know about obtuse angles. And where I got to that step right down here, so this working's all the same. When I got down to the step sine x equals 0.8753, your calculator will always give you the smallest possible angle, the acute angle. It gave me 61.1 degrees. You can see if I drew that on my unit circle, that'd be about there. Remember the unit circle, it goes up to a height of 1, so 0.8753, it's nearly at the top. But there are actually two angles that will give me 0.8753 when I found the sine of them. The first one is x. The second one would be 180 minus x. You can see that line there. That's the one that, when I measure the angle from 0 round to that line, is also responsible for a sine of that angle being 0.8753. if we look at what it would look like in the triangle, you can see I've added in that 11 centimetre side could just as easily be angled back towards the base and towards this angle 37 rather than away. It would still be 11 centimetres, so there must be two possible triangles for that bit of information. What's the other angle? Well, you just need to remember your unit circle, your best friend in maths. If I go 180 degrees minus that 61.1, 118.9. Is that reasonable? I think it's going to be, because 118.9 plus 37 is still going to be less than 180. So you're right. Now, that's something you'll need to watch out for when you're doing your exam, because almost definitely your maths teachers are going to want to make sure that you can show your understanding of the ambiguous case. So sometimes when you're finding an angle, there's more than one possible angle if you're using the sine rule. Other than that, the whole section is just sticking numbers into a formula and using your calculator, so pretty easy. Cosine rule. Cosine rule we can use to find a side or an angle as well, but we have different bits of information. For the cosine rule, when you're finding a side, you need to know two sides and the included angle, not the opposite angle this time, but the angle in between the two sides. And then, look at that. It looks remarkably like Pythagoras' theorem. And in fact, if you remember that the cosine of 90 degrees equals 0, you can see that it is Pythagoras' theorem. It's just that in Pythagoras' theorem, all that bit you subtract away is equal to 0. How do I go about solving these? Pretty straightforward. Given some information, I want to find x, so it's going to be x squared equals 5.2 squared plus 4.5 squared minus 2 times 5.2 times 4.5 times cosine 58. Sounds easier once you've done it a few times. Go ahead and fill in the blanks. Work out the right-hand side using your calculator. Find the square root, round to 2 decimal places, and you are done. Not too bad. I promise you could do more than find a missing side. You can also find an angle. You can see here they've given the rearranged formula. I tend to just use that formula and rearrange it myself. You've got a summary sheet this year, so it's okay to use this. Otherwise, in the future, I think this one's the easiest one to remember. You probably just want to remember that and rearrange it. Plus, that gives you a bit more practice at your algebra. So if I know the three sides, I can find the angle in between, or the angle, any of the angles with ease, just by substituting in the values. In this case, I want to find x. I'm going to replace a with x, so I have to replace the opposite side in the formula, the one that's getting subtracted, with the opposite side of 12. The other two sides, whether it's 11 squared plus 9 squared or 9 squared plus 11 squared, doesn't matter. Cosine x equals 58 over 198. Cosine x equals 0.292929. Obviously, that's 29 recurring. Arc cos, or the inverse cosine function, will give you the angle 72.97. Good news is, no ambiguous case. You know from your unit circle, cosine's only positive between 0 and 90, or in the fourth quadrant, way around between 270 and 360, which you're not going to get in a triangle. Little summary there. Cosine rule, can use it to find a missing side if I know two sides and the angle in between. Can use it to find an angle if I know three sides. Sine rule, if you're looking for a side, make sure the little letters are on top. If you're looking for an angle, make sure the big capitals are on top, the sign of the angles are on top. And in that last case, you may need to look out for the ambiguous case. I might put up a few proofs showing how you prove these rules, but for now that should be enough to get you started. Let me know if you have any troubles. Cheers.